Advantages of 802.11n. The very first one, which is a very good advantage, is spatial multiplexing. Okay, so to understand this, you have to understand the concept of radio chains. Okay, now we have an access point, or we have a client. Let's say we have an access point. Then instead of having one antenna for a radio, we all know that the AP has 2.4 gigahertz radio and a 5 gigahertz radio. Now instead of having one antenna per radio like we had in ABG, one antenna per radio, the standard supports up to 4 antennas per radio, which means I can have, in a way, if I write this, it means I have 3 transmitters and 3 receivers. Okay, if I do this, it means we have 3 transmitters, but I have 2 receivers. Okay, now if I write something like this, it means I have 3 transmitters and I have 3 receivers, but I have 2 unique streams. Means, I'll explain this with the help of an example right now. So this is what you have to understand. The AP looks like this now. Okay, which is 3 transmitters and 3 receivers. 3 transmitters and 3 receivers. This is the concept of radio chains. We are chaining the antennas together. Now, when I say, let's take this into consideration. We have a client, or a transmitter A wants to send traffic to transmitter B. It wants to send 1, 2, 3. Since it has 3 transmitters, okay, let me change this a bit just to make it easy. Let's make it, we won't take this example, we will take this example for now. 3 transmitters, 3 receivers. Instead of sending the data through a single antenna, it uses spatial multiplexing to parallelize the beam towards the receiver. So 1 will be sent from here, 2 will be sent from here, and 3 will be sent from here. 1 will be received here, 2 will be received here, and 3 will be received here. Okay. Now, by simple maths, if we are doubling or tripling the streams and more data is being sent at one time, instead of sending first 1, then second 2, then third, in the third stream sending out 3, we sent 1, 2, 3 together. And 1, 2, 3 was received here together, because this is also, let's say, a 3x3 client. Now with simple maths, we are doubling, I'm sorry, let me just correct that. Doubling or tripling the throughput, right? That's what we're doing with this. The second important feature that came out in .11n was beamforming. Okay, by the way, if there is a scenario where it's a 3x3:2, which means 2 unique spatial streams, if in a communication between a client and the AP, any one that has a lower unique streams setting, which is, if the client is 2x2:2 and the AP is 3x3:3, then the AP will come down to 2. The client, between the client and the AP, there will be 2 unique streams exchanged at one time. It will not go to 3, because it cannot communicate on 3 spatial streams since the client is a 2x2. So yeah, that's just something that I wanted to mention. Beamforming. Now, beamforming is a very good feature. However, it was not widely implemented in .11n. For beamforming to work, what beamforming is that from this transmitter to the receiver, I am kind of directing my traffic to a specific location, to a specific, in a closed arena. I am doing beamforming towards the receiver, which means the kind of technology that is used in .11n, beamforming were of multiple types: transmit beamforming, and of course 3 or 4 more types of beamformings were supported by .11n. Now the tricky thing about beamforming is that the transmitter and the receiver, they both need to support same type of beamforming technology. So this is like directing the beam towards the receiver from the transmitter in a proper channel. And thus, since there were scenarios many times when the transmitter and the receiver were configured with different types of beamforming in .11n, even though the standard supports this particular functionality, but it was never widely implemented in .11n. So .11n is not known for beamforming, even though beamforming was launched in .11n, but it was never taken advantage of. Beamforming was efficiently used in .11ac, which we will cover in the following videos. The third advantage of which was launched in .11n was echo cancellation. Kind of like how we are taking advantage of multipath. Using echo cancellation, we are taking advantage of multipath. Now how this works is, if from a transmitter to a receiver, what multipath is that the same beam is reaching from multiple directions, right? Here, like this, it can go and reach here like this. Now what echo cancellation does is it uses something called a digital signal processing technology inside the AP, which can distinguish between the arriving beam and the original beam and the arriving beams which are late, and it pushes the arrival time of the next beam by bit, by some amount of time, which is how we now make sure that all the beams are received at the receiver at the same amount of time and in phase. Before processing, it waits here for some time for all the beams to arrive, and then it understands using DSP that I need to make some changes to the arriving beams so that all of them can be in phase. So now, using DSP, multipath is always helpful, or I should say is always constructive in .11n. This was a huge advantage in .11n technology because we were always worried about how multipath was ruining the Wi-Fi connectivity and Wi-Fi transmissions in ABG. But echo cancellation along with DSP, digital signal processing technology, we were able to take control of that and make sure multipath was always helpful to us. More advantages in the coming video. Thank you.